Hi, good evening to all of you and welcome to this session of ACM India and iSIGCSE Education Webinar Series. These webinars have been organized once in every 2 months. I am Chitra Babu, Chair of ACM iSIGCSE Chapter, the Indian counterpart of the Special Interest Group on Computer Science Education, as well as Professor of Computer Science and Engineering at Sri Sivasubramanian Nadar College of Engineering, Chennai, and I will be your host for today's session. Before we start, a few things about the webinar as usual. The audience is in silent mode at all times. At any point of time, you can log your question in the chat. We will take your questions at the end of the talk. We will try to address as many questions as possible, but we will be limited by the time of 60 minutes allotted to this webinar. Since this is an ACM initiative, it's only fair that we spend a few minutes to understand what ACM India is all about. You can see ACM India at a glance on this slide, but let me give some examples of what being a member of ACM means. You will be part of world's largest computing society. Out of the 1 lakh members worldwide, about 10% of them are from India and half of them are students. ACM India is spread across the country mainly due to its chapters. We have totally 20 professional chapters and 200 student chapters across the country. As a chapter, you get access to ACM's Distinguished Speaker Program and also ACM India's Eminent Speaker Program. You can invite any expert from these programs and ACM will take care of the travel. DSP is already available on the virtual platform and ESP is also available right now. We also have the Best Overall Student Chapter Award, Best Chapter Website, Best Emerging Chapter, Best Chapter in terms of activities that have social impact, Best Chapter that has recruited maximum members, and all these awards carry a cash prize. ACM India regularly organizes summer and winter schools for students in different research areas in computer science. Faculty for these schools are drawn from prominent academic institutes and industry. 3 summer schools have been planned this year in the area of data science, AI/ML and shape modeling in the month of July. The special interest groups in India organize national level conferences and symposiums like CODS, COMAD, ISEC and Compute. Compute will be organized this year during November 2nd to 4th and the accepted papers will be hopefully indexed in ACM Digital Library. The approval is currently under processing. Faculty members, I request all of you to seriously contemplate making submissions to Compute. We have student scholarship program to attend these conferences. Please visit the respective websites for more details. We also have something special for promoting gender diversity, ACMW, which works for empowering women in computing. It has many initiatives specially targeted for female students. We organize Lady Ada programming competition and hackathon specifically meant for female students. We also have one of the summer schools exclusively meant for female students. This year it is organized during July 11th to 22nd, jointly by the Robert Bosch Center for Data Science and AI at IIT Madras and PSG College of Technology in the area of data science, AI and ML. ACM India has instituted 3 prestigious awards. Early Career Research Award presented to individuals in their early career who have made outstanding contributions to computing while primarily working in India. The second one is Outstanding Contributions to Computing Education Award. The third award is for Outstanding Contributions in Computing by a Woman. Now it is my pleasure and privilege to introduce our today's speaker, Professor M. Balakrishnan, who will be giving a talk on embedded system design projects for social impact. Professor Balakrishnan is working in Department of Computer Science and Engineering, IIT Delhi for the past 33 years. He has been involved in teaching and research in the area of digital systems design, electronic design automation, and embedded systems. It's not moving. Okay. Further, at IIT Delhi, he has initiated a number of programs, activities to promote research startups as well as outreach to the community. ACM, a laboratory and research group founded by him along with Professor P.V.M. Rao of Mechanical Engineering. It is involved in developing a number of assistive devices targeted towards mobility and education of the visually impaired. Professor Balakrishnan is a fellow of ACM and also a fellow of INAE. He is a recipient of the ACM Eugene L. Lawler Award and IIT Delhi's Lifetime Achievement Award for his amazing work in the space of differently abled. Welcome, Professor Balakrishnan, and over to you. Yeah.
Thank you. First of all, I would like to thank iSIGCSE for giving me this opportunity to make a presentation to all of you. Let me share my screen. So let me apologize. I have a little sore throat. So at some point in time, if you find that my voice is not very clear, I will stop, drink some water, and then get back. Are you able to see my screen now?
Yes, sir.
Okay. So let me start at the beginning. Okay. So, I find it's also not moving. Just a second. Okay. So when I started teaching at IIT Delhi, there was already a course called Microprocessor-Based System Design. It used to be a third-year core course. And what we used to do there is, many of you may be familiar with, we used to use kits. Of course, kits changed as the microprocessor evolved. So you have 8085, 8086, or 8031, or 8051, like, microcontroller kits. But primarily, the nature of experiments and the nature of what the objectives of these experiments were not very different. People learned assembly language programming, people learned how to interface various ports, various devices, program various peripheral chips. So this was the type of work that most of the student assignments were done. Students found this extremely boring. The reason was that students have already done a course on computer architecture earlier on before they came to this. They had done a course on digital systems, they had done a course on computer architecture. So conceptually, there was nothing much in this course. Okay, so a lot of details of learning how to program, know about registers, their functionalities, port descriptions, how UART works, protocols. So these are the type of details that the student learned, and students typically, are not interested. And also the world has changed, and I'll come back to that in a moment. And that change is very important for us to recognize. It so happened that I went on leave for a year and sent a sabbatical in Germany, in University of Dortmund. And I saw something very interesting. They had large group of students working on projects, semester-long projects, along with their other courses. And they delivered something very, very, very substantial at the end of the semester. What I found was they were doing mixed hardware software design, even sometimes using some FPGAs and so on and so forth. But they actually did not have that much of a training in digital systems as students at IIT Delhi would have. And clearly also in terms of the caliber, the way that we select students at IIT, the caliber of competence is extremely high compared to a typical university system. But that did not matter. The amount of actually the nature of projects, so I was part of the evaluation team for their projects, and I was quite impressed by what they achieved. One fundamental change I looked at it is there's so much of learning material that is actually available easily to the students, so that students can actually do a lot of self-learning. And that was a very important part of these projects. Very broadly, specifications were given, and that was clearly the role of the instructor, or very often the teaching assistants, who actually handled for the professors this particular course, the individual projects. And so beyond that, the students were sort of very excited because they were implementing something. They put in all their efforts to actually demonstrate. And the demonstration at the end of it was more or less open to the department. Many people came in and saw this, and that also provided a certain excitement to the students. So there are many aspects to this, and I tried to look at what are these aspects which makes these projects to be so successful, and I adopted it in a course. So I renamed the course. So unfortunately, IT system gives you a lot of autonomy in terms of restructuring courses. So instead of microprocessor-based system design, rename the course as Embedded Systems Design course. These become open-ended project. And concept demonstration, either depending on what was the starting point, either they demonstrate a certain concept or build prototypes. The specifications were drawn up, and later on, as you will see, very often the students did build on work that was already done in the by the previous batches. So it was not always that. So maybe one group has already demonstrated the concept, so then other group can actually, the other batch can refine it and get to something more elaborate. Specification, design, and demonstration all were significant part of this particular project. Lot of emphasis on demonstration in an open forum. I will come back to this, how was this achieved. Groups of 4 to 6 students, though in Germany I found that even 10 students could be working together. So this was moderated because we did not want many of the students who may not just be, a small set may be working and other students may be just sort of using that work that is being done by the other students. So we restricted it to, so that it's possible to do a little bit of a subtask monitoring in terms of what students have done. I also encourage students to come from different disciplines and work together, not always successful. But many times students from mechanical or even sometimes students from textile or chemical will join students with computer science and electrical to do the project. I also defined something which was very unique. I defined a group prerequisite. Normally, when we say that a student has to register for a course, you need a prerequisite. That means that the student should have done a certain course before they do that. Because for this course, I wanted students to have done digital system design and computer architecture. But I did not insist that every student should have done computer architecture and digital system design. It was okay for me that some students were just doing some hobby robotics, or they were in some robotics club, or they were, as long as, let's say there are 6 students, 2-3 of them have done these courses formally, it was good enough. But others have, let's say, played around with, so there are other opportunities in our system for students to play with microcontrollers and sensors and devices. And it could be a Formula 1 car design, or it could be a robotics, or some type of hobby club was also accepted as a prerequisite, as long as others have done the course. I took 3 broad themes: assistive technology, smart campus, and sustainable habitat. So this was also because of my own experience and my own, let us say, interactions that used to happen, because I will talk a little bit about how projects got specified. And that was important, that there are opportunities for me to come across new problems or new challenges that occur in this field so that I can translate them into. So in this case, if you see that smart campus was clearly basically observation of what was happening around in the campus and trying to define, and I will talk about some of the interesting projects that happened. So this was the course. So I'm just giving you a very broad, these are neither sort of comprehensive, this is not a complete list of courses, just to give you a glimpse of the type of things that they happen. So I'll come back to this. So for example, the first 3, which are actually in blue, these are all courses related to assistive technology. So they did LX's, our lecture hall complex. So one group tried endo navigation assistant, sound map, depth map using ultrasonic sensors. Pratyaksh was a compact wristband that actually could give you information on obstacles by certain pins which will move up and down and make them aware whether it's left or right. Smart notice board was an interesting project. I'll come back to this. It was a campus-wide display, traffic monitoring, campus speed monitoring, smart fan switch. I will again come back to some of these projects a little bit as I go ahead. Persistence of vision was a commercial device which are available students themselves found. how to write characters on a cycle spoke. So they had an LED string, and when the cycle rotates, it's actually, if you can supply the inputs in a proper format, so you could actually make images, or you could even write something. And it will look like as if as the cycle is moving, something is actually getting written on the cycle wheel. So this was a project the students themselves came with and demonstrated. So let me talk a couple of them a little bit more detail. So in sense of example, look at the smart fan switch. So it was nothing but I used to see that in the lift lobby in our main building, as it gets very sultry in the month of, actually start summer, and as well as when it becomes hot as well as sultry. So even anywhere starting from April to October or November, there was a fan which was continuously getting operated. So, so for the people who are standing waiting for the lift. And very often, obviously, as you can see, the lift is not occupied all through the day. Of course, definitely not in the night, but even during the day, there are peak periods, there are, class timings, there are lunch timings, when there is a lot of people waiting, but very often there was nobody, but the fan was still on. So these students just did a project of actually recognizing whether there was, this is a camera-based solution, and they had to detect whether there were people who are waiting, and then they operated the switch to be whether the fan to be on or off. Fairly simple project. Today there are a lot of tools available for recognizing faces or recognizing people, and all types of solutions are available, but they had to actually did this, and they successfully demonstrated it happening. Smart notice board was a very much more elaborate project. It continued over 3 batches actually. And the whole idea was that we have lots of departments, lot of sections, lot of student clubs, lot of hostels. Everybody generates some information, notices, and they all have a clientele. For example, if there's a hostel mess secretary, he wants to put up a notice, it's only for his own hostel, students who are members of that mess who reside in that hostel. If a department wants to make a lecture announcement, it wants to make it to a certain group of people. If institute wants to make a certain announcement, it might want it in all the hostels or all the academic units. So this particular notice board system was a distributed notice board system where there are a large number of people who deposit a notice, it gets distributed. And each of these digital displays, basically an LCD screen that was installed at many, many places. They had a small filtering mechanism, which will actually filter out the notices which are meant for that particular display. So when you are actually, so you have channels, you are in some sense, you subscribe to some channels. So notices are coming on various channels, and each of the display boards subscribe to some channels. And any notices coming on that will get displayed here and then rotated. So the project was very interesting. It was actually implemented, and many years till COVID struck, it was actually operational in the campus. So the inclusive classroom was a project which is to access to projected information. So if there is either a low vision or a visually impaired student sitting and there is a projection happening, he or she can hear the sound, but he cannot see what is actually being projected on the notice board. So today it's fairly possible that, and if the slides are happening, so we detected when a new slide has come, the slide was, images are taken, OCR was done, and then transmitted through the Wi-Fi to all the people who are sitting in the class. And let's say maybe even it could also be a large lecture hall where you're sitting behind. You have a reasonable eyesight, but you can not still see what is being written on the board. So this was, so you create an image of that on your local screen that you may have, a tablet or a laptop that you may have. So there are many such projects. So we had a whole string of projects on service monitoring. So if, one of the things that I noticed was that one great thing about services like Ola and Uber, and suddenly the whole behavior of the drivers had changed in terms of, because of the rating system, because of the fact that each of the clients in some sense has a mechanism to tell to the operator how was the performance of the driver. So there is a very significant, especially in a city like Delhi, one can see that there is a significant improvement in the performance of the, in the behavior of the driver in terms of their politeness or, another behavior. So the problem in many of our situations is we don't have such a feedback system, lively feedback system. So one group of students created this just using a QR code and some software to be able to mobile-based software so that it can all be accumulated and the feedback given. And we did something similar for garbage collection, something similar for, so other groups worked on other things like, toilets are cleaned or not. So for example, even today you go to a public toilet, you see a sheet of paper where somebody has to sign when they have cleaned or not. Why not? It can all be automated, and where you just deposit a picture after you are clean. And all these QR code and GPS can ensure that the cleaning is happening regularly. And even if the pictures are there, it can even be automatically rated up to the cleanliness if you have enough data to be able to train a network to be able to see that. So these are some of the interesting things that students did, which are all very local. I'll come back to this navigation assistant when I talk about my assistive technology project. But this was a pilot which was going on in All India Institute of Medical Science, where we're installing an indoor navigation system and students participated in it. And then there was, so deboard, for example, in the smart campus. So how do we, either it could not just for a visually impaired, even for a stranger or somebody who doesn't know the local language, and if you are on a bus, how do you actually help the person to deboard? He or she knows that which particular stop he or she has to get down, but how do you know that that particular stop has come or it is going to come? If it's a crowded bus, you have to start moving so that you actually reach the exit door when the stop comes. It could be a language issue. It could be, an issue of, in our case, it could also be an issue of visual impairment where one needs to be alerted. So a GPS-based solution, which actually the route GPSs are known, and then, of course, so we can keep track of the stops and we can inform them beforehand when the person comes. Again, this particular project was implemented on the IIT buses, and we showed that this could actually work. I gave you a glimpse of some of the projects over the last 3 years when it was operational. Unfortunately, obviously, 2020 onwards, the course did not happen in this mode because the students were not in the campus. I did talk about intelligent display, but let me, for example, at some point in time, even actually before sometime in 2000, I think 12 or 13, we implemented a Pick Me service for campus rickshaw calling service. Just like you can call, so any user download an app, and this all the campus rickshaw people at that time, they didn't have the smartphone, so we did give them the smartphone from a project, and they could actually you can find out which are the 3 nearest rickshaws which are free, and you can call them and they can come and pick you up. So it was a solution that actually was implemented, and this solution was operational for some time in the campus. So what was the course flow? So the course flow was that announcement and meeting with interested students before the semester break. So the courses actually was happening in the 2nd semester. That means it will start in early January. So we will I will have a meeting in early December when the students have just finished the previous semester. Students typically came from both 2nd year and 3rd year. Though there were some students from 4th year, only the 1st year students were not, because the prerequisites and other requirements, and they also had other coursework which was much more, did not permit them to register for this course. But we had a good mix of 4th semester and 6th semester students and a few 8th semester students. But I will meet them and I will discuss with them. I will have a list of projects, and this list of projects that I talked about, I will be collecting almost through the year. Okay, so I will keep on noting down, let's say, what are the things. But I'm also, very often the students also, sometimes the students will also come up with their own ideas, and if those ideas fit in the framework of the course and they could actually implement it in a semester if I felt, then they could also work on those projects. They will present and discuss projects in 3 streams. I already talked about it. Students to form project groups, and as I said earlier, I sort of encourage them to form interdisciplinary groups. There are 3 presentations, specification and methodology. So that was around 2 weeks into the semester, they will make first presentation. Second presentation will be typically, because the students came from very different disciplines, years and so on, getting at times scheduling these presentations was typically on a Saturday. So whole of Saturday afternoon, morning, half the groups, 8-9 groups will make a presentation. Afternoon, 8-9 other groups will make a presentation. Methodology and progress. So that was the second presentation. And then that will be a 4 weeks into it. And after 4 weeks of that, there will be progress and demonstration. This will include the poster plan. The final evaluation, I always tied it to the Institute Open House. So this was very important because I felt that students actually get more encouraged if there is a public demonstration of the work that they have done. It excites them more. And they could also, if they had any family or relations, anybody in Delhi, and if they want to, because anyway, it was an Institute Open House, anybody could come to the campus. So I also encourage that if you have any friends or anybody who would like to come and visit, let them also come. I formed a jury of 4 to 5 people, people who have such interests. So they came from both my own faculty colleagues as well as some of my industry friends who were interested in such projects. And this jury gave a feedback, and this feedback was also used in their final grade. This was all about the course plan. For example, this was one poster that of one group. I talked to you about the deboarding. Similar posters each group has to prepare, and this was discussed and this was made there. I'm going to change the flow now. And I did talk about various types of projects that we were doing in the 3 streams. But one that was very close to my own passion is the area of assistive technology, and more so focused on education mobility of visually impaired. And this is something that I had been working on for now nearly more than 15 years. And I had some success in taking lab to the user. Note, whatever I'm projecting, all of them started as a project in this course. It didn't end there. So later on, it went through many refinements, external funding. And in some cases, the students who started it continued with it. In some cases, we used other project staff for students to complete it. But what was important from this particular presentation point of view is there was a link to this particular course. The initial idea that we tried were all part of this particular course. So pedestrian mobility challenge is something that knee above. So if you look at it, the challenge is that people using a white cane, they cannot detect obstacles which are above the knee, because the cane can only detect obstacles below the knee. And if there is a projected, there's an obstacle projecting onto their upper body, they can cause upper body injury. So we want a knee above obstacle detection. And of course, we also want things like non-contact detection, because if a dog sleeping, if you can only touch and detect the dog, it can cause it could be a safety issue, because depending on, the dog could react depending on where you're touching it. And so this was a device which is, of course, today a very popular device, which we started with this. Note, all of this did not come through this particular course. So this is also, I would like to give a warning at the end of the this particular talk. But it was a simple ultrasonic ranging device, but a lot of other user optimizations were done later on in a project, and with also a very major funding from Wellcome Trust before it reached. But the students who started working on this project were very enthused. They actually were dual degree students. They first came to me in 3rd year, and then they continued to work on this for 3 years and made many, many refinements. And so that gave us a confidence to go out and seek external funding. Even the first set of user feedback was collected, and there was so much enthusiasm among the users that we were able to get the device up. Okay. So similarly, this is the other project for public transport. So for a blind person, the 2 challenges: what is the route number is one can see, but also what is the entry door? Where is the entry door is another challenge. Even if somebody tells what the route number is, because very often in Indian conditions, the buses may not come to the bay. They may not even be possible for them to come to the bay. There may be a lot of crowd. There may be other buses standing because, as you can see, many route numbers come onto the bus. So we designed a system which is, we call it on-board, which is a receiver transmitter system. A user carries a small device, a remote-like device with just 2 buttons, and there is a controller and a speaker on the bus, installed on the bus, which can respond and which can tell. First of all, the user can collect all the route numbers from the buses which are in the vicinity, and it speaks out. The device itself speaks out, and once you make a selection, if the route number of your interest, then it gets locked on to the particular controller on the bus, and then the bus speaks out. And the speaking, the audio from the bus can actually give you a cue to which direction the user has to go to get onto the entry door of the bus. This is a device called onboard, done a lot of testing. Unfortunately, it is still not installed. Now where some very serious talks are happening, and hopefully in a couple of years you may see them on buses. So it's a globally unique solution and patented by us. But the first devices, the very first devices started in this project. The other project is on mobility and navigation. Again, we tried many things here. Solution which is based on basically images followed by machine learning, where you're doing object detection, face detection, dog detection, signboard detection, multilingual hand-painted signage, and finding out familiar faces using both face detection and face recognition. And it's a device based around neural accelerators, which we are presently developing, and some very, very preliminary testing is happening. So that, again, now it's a project, now it's a sponsored funded project, but very early trials on this were done in this particular course. Let me not go into it because the indoor navigation is another one. We have done a number of projects from this particular course, which is for independent indoor mobility. And there are many, many parts of this particular project, which students have worked on. How do we make programmable beacons, which are so this is a mobile app, and this mobile app for localization uses the beacons installed in it. And this is the project I mentioned, that All India Institute of Medical Science, we have one of the first installations, pilot installations. Now we have another installation, National Institute of Blind. And this is now coming out. And now it's of course not part of this particular course projects, but we did a lot of students worked on this various components of this project. We call it Include now. Inclusive navigation. So this is a picture of the layout of the All India Institute of Medical Science Rajiv Prasad Ophthalmic Center, which is this is what I wanted to present because I would like to have a lot of time for question and answer, and now I will open it up for discussions.
Thank you, Professor Balakrishnan, for that very interesting talk. Audience, if you have questions, since there are very less number of people, even you can unmute yourself and ask your question directly. Or if you have any questions, you can enter it in the chat box also.
See the chat box. There is.
Or if you would like me to unmute, so you are not able to unmute, or I have to do something, please let me know in the chat box. I can unmute you, and then you can directly ask the speaker whatever you want to ask. Yeah, there is a question from Jaswant Kumar. If the first years have relevant skills, can they join in doing these projects, sir?
Yes, it's possible, because what is happening increasingly is not everyone, but some students start playing around with microcontrollers, sensors, even in school now. So if the students have had exposure to these type of devices, so if you look at things like Atal Innovation, those things are actually reaching the school. So at the very basic, some of the projects are much more complex because, for example, we are also talking about using AI/ML techniques, and if you are making optimizing models and so on, that may not be possible. But clearly, there are many things that can be done, which are interfacing sensors to be able to make certain controls or even make communication. So one of the very important things to realize it, and that's what I would like to emphasize. Two things I would like to emphasize. Very often we make curriculum where we want to teach everything. That's something I think we should change. Students there's so much of material is available, so much of support is available on the net. And this is what they have to do throughout their lives. So we should increasingly encourage students to do things by themselves. So it is not necessary that, it's also like many of the things that students are done. I have, clearly I have no experience in doing those things, but the students can find out how to do that. There's a lot of support available. That's first thing. And this actually excites students a lot because it's more. And once we say that there is a motivation that I want to demonstrate, then they try to figure out where to get the help from and how to do it. Second thing, very often, and this is something people make a mistake, these projects don't become products. Okay, very often people think, oh, I made this, and these are all concept demonstrators, or these are all things which are actually, at best, they could be prototypes. So a manufactured product, whether it's hardware or whether it is software, it requires a professional engineering. And that students typically neither have time, nor the resources, nor the aptitude to do that. Okay. So it is very important that people don't think them as products. These are concept demonstrators, or at best prototypes. And they need to be, know-how has to be transferred to either to an industry, or they should take it up as an incubation. Take it up in a full-time mode, only then they can become products. Okay, that's very important. Yeah.
Another student has asked, that is, they are doing computer organization and digital design course, but I don't have much experience with this kind of hands-on work. So will you give some guidance and optimally when I will be able to contribute with projects? One student is asking. In fact, another student is also, Suraj Yadav is asking, can we become part of these projects in internship mode if we are not from IIT?
No, you have to understand that capability to mentor large number. So if you really look upon it, there could be two issues: whether you have access to resources, that is an issue. That is one issue. But the other thing is peer group. The peer group is extremely important. But what I'm essentially trying to emphasize is the internet provides you the peer group. There are always a lot of people working on the projects. You can interact with them. And many of the resources are not very expensive. Okay. For me to say that, yes, can you become an intern in my lab? That's very hard for me to say because, there are a large number of students already working. Our numbers have also increased. Our capability to take many more students is limited. But if you have a motivation, I don't see any reason that you cannot do this. Some of these boards are very inexpensive. You can even buy them, but I'm sure many colleges can also support you in terms of both sensors and boards that are there. So the challenge is to get a project which is innovative. That is a little bit more tricky. And if you are not a user group, you need to move with them. For example, in assistive technology, we don't design what needs to be done. The functionality is defined by the visually impaired users with whom we interact. So you need to interact. If you're not a user group, if you're designing for somebody else, let's say you want to work for certain community, let's say older people or farmers or anything, whatever interests you or whatever is accessible to you, spend some time, which is called the immersion, in terms of talking to them and get their real needs, not the perceived needs as you think. That's very important, and then you may get very innovative ideas to be able to do that.
Another question is where PG students and research scholars also involved in these projects and in the delivery of this course.
So the research scholars and some PG students are involved as PAs, and sometimes they also get not as the, so this particular course is not open in IIT Delhi for postgraduate students as per credit, but I do have to have 4 to 5 TAs for this course depending on my registration. My registration at the peak has gone up to even 70 students. Please note it's an elective course, it's not a core course for anybody. Okay, which means that the students come here because they are interested in doing something in this space, and that's how I like it. Because core means that there are a lot of students who are not interested, they also come and then they spoil the whole ecosystem of the course. But here the students come because they want to tinker and do something. But I have, if there are, let's say, 60 or 70 students, I would have even 5 to 6 TAs. And those TAs are typically either PhD students or MTech students. And I have seen that some of them, not all, but some of them have really got involved in the project, sit down with the students, help them, and also learn in the process a lot. But not formally, they are not registering for the course.
Sir, would it be possible for you to give some pointers for the resources so that it will be helpful for a lot of students to take such kind of projects?
I don't know, means pointers.
In the sense, some online resources where they can get started with. This is again a question from some of the students, like some resources where they could get started with doing some projects by taking guidelines from the online things. And
okay, so a lot of this, assistive technology, as I said, we do have a list of projects, but these are all for people, visually impaired people. We do have projects which we work on. For others, like for example, for the smart campus, most of the projects are based on observation, what needs to be done. For example, I told you about an intelligent display system. This is a project I'm sure in any campus, you can do it. And if you have a large enough campus, and even though we said concentrated on campus cycle rickshaws, but you could also create a group of people. It could be auto, it could be anything. So one thing is, of course, now the Ola Uber solutions are very popular, so maybe there's no need for it. But cycle rickshaws are not covered by that. So if you live in a town where there are cycle rickshaws, you can implement that. There are many such projects which I talked about, for example, very often you have situations where energy is getting wasted. So you think of a solution where you can actually, save energy by automating a switch, and that switch automation will depend upon what is the functionality of that particular appliance that you're using. So I don't have, I can give you some links in terms of where some of these projects are described that I can give you.
Okay, sir. Okay.
That I can do. But
okay, sir. I'll get it from you later and pass it on to all the people. And another question from Jared is ethical clearance important for these projects? If yes, should it be taken, that clearance be taken before building any of these assistive products?
So typically, ethical clearance is required if you are going to do a user testing, which could actually have. So we do take ethical clearance for, let's say, for example, our All India Institute of Medical Science project, where we have doing a lot of user testing, we have ethical clearance. So if you are doing it formally so it's also required sometimes by publications in the assistive technology. So very often the projects, anything which is psychological, anything which could actually impact in terms of a person's behavior, ethical clearance is very important. Okay. So, but if it is something as an educational product, though, of course, as I said, if you have to do a major user testing, you will need ethical clearance. But very initial functional testing you could do with people who are, rather than an external ethical clearance, you can always get them a certain agreement to sign, and that should be good enough.
Another question from Professor Aniruddha Bhattacharya from KL University. So he's asking, what are the security measures in these models of smart sensing technologies?
So there was only one project where we actually had to do security issues, which was a smart metering project. Okay, where we were doing energy metering, and so which essentially means that somebody could hack into it. And there are solutions available. So please remember, these projects, there's no expectation of research. Okay. These are second or third year students. The focus is on putting things together which are actually available as modules. Think of a system, think of a specification, think of a system and implement and so we are not doing, so if there's a security module available which will make it, so they just have to integrate it into the design. But the idea of this particular course is not really to do any research on security protocols. That's all beyond this. So this course is a system building course. The whole emphasis is in putting the system together, which could be software on embedded platforms like mobiles, or it could be on actual embedded devices which you actually build using things like Raspberry Pi, Arduino, and all types of devices and sensors that you connect.
Thank you, sir. Yes, I personally see this as nowadays, even in curriculum, we are emphasizing all these sustainability development goals, SDGs, which they call, and a lot of these things are really making sense. So how energy can be saved, or how you can build such kind of projects. And in our institute also, from second year onwards, or sometimes from first year onwards, they build projects using these kind of Raspberry Pi boards. Now they are even using Jets and Nanos. Yeah, I find it very, very.
I think the important thing was, for example, I told you that smart fan switch. The important thing was not that the idea is great, anybody could think of that idea. It's just that the deliverable was they had to actually make that, operate that and demonstrate that that particular fan, the people are not standing in front of it, it switches off, and that
automatically, yeah. So,
and when people, that was on the day of the open house, they had to demonstrate it working. That was the emphasis of the course. Okay.
Yeah.
And they had to somehow reach that stage. Efficiency was not a great issue. It was not like, so those things can always be, it was not a product. It was either a concept or a prototype which they had to. And in this process, very often the students will go and get something 3D printed. They may have, so for example, in the whole group, there could be one person who is actually, as I told you, I talked about group prerequisites. So if there's a mechanical engineering student who is more interested in design, he will actually do the 3D printing for the group. And that was his contribution to this, apart from other discussions. So it was interdisciplinary group. So another thing, this is something that we need to learn to work with people with who are in different disciplines. So that was also attempted, not always successful, because I was never forming the group. They will form the groups themselves unless they say we can't find group partners. Sometimes all electrical engineering students will sign up together as a group. Sometimes mixed groups will sign up.
Yeah. Some other student is asking, is there any public access to the already completed list of assistive projects at IIT Delhi?
Assistive technology products, you can go to our AssistTech website. So just say AssistTech IIT Delhi. You will see a lot of material, projects, publications. So that's a website which is, and you will get a lot of information on that. But not on all the course projects. So unfortunately, I have not documented them as well, so that all the other students could use. Perhaps now thinking back, I should have done it, but that's not there. But on the assistive technology, because these are not, we start with student projects, but take it forward and go to the users. But other projects, many, for example, the campus traffic monitoring was a very successful project for many years. We could, we worked again on this project for 3 batches, and then followed by some MTPs and so on. At the end of it, we had multiple camera installations in the campus where if a car speeds up, their license plate number, everything, the security office could actually get the online information on everything. Even if they could get information on whether this particular car number has, in the last 1 week has violated traffic restrictions 10 times. All those bar graphs were available. Unfortunately, with COVID, everything, and recently my security officer asking, can we regenerate the project? Because, there was no traffic during the COVID time.
Yeah, yeah. And personally, I'm curious to know that you mentioned that research was never emphasized in these projects. It was all about system building. In this course. But incidentally, did anything like some innovation came out, and then later you chose to publish that part of it or patent that part of it? Some such things came out of these kind of projects which were done as part of this course. Yeah.
No, I will not say as part of this course, but for example, as I told you, Onboard started with this course, and we have a patent, and as a globally it's a unique solution. But so I would not say it was not at a stage of patenting when this one semester ended. So they just put things together and they don't optimize, they don't, because once you have to have patent, you have to also compare with global solutions. So many things have to actually happen. But these students continued for it for more time as their other major projects and so on and so forth. And then we got some funding from BST. And now we have a solution which we piloted and things like that. See, we have to realize that this was not a course where it was a 4-credit course, and typically students are doing 4 to 5 more courses along with this, at least 4 courses along with this project. So they had fairly limited time to do this. Like they was just spending time like for a 4-credit course, maybe 6-7 hours per week or 8 hours per week. And so clearly what could be done here should be. So that's why when students came with very ambitious specifications, I would not accept it as part of this particular project course. There has to be a clear idea of whatever 4 or 5 students coming together, how much they can do in a 4.5-month semester. That is very important. And finishing was very important for me. It was very important that it is not that some code is developed and so on. It was very important for me that they actually do the demonstration on the open house. That was a very important part of the project. And that made it exciting, but that also made it, that's where most of the effort went rather than, Ideas were very often innovative, but unfortunately in India, you can't patent an idea. So if you could, and I would say that most of the time, the ideas did not come from the students. The ideas came from my discussion with others. Sometimes, yes, students also came up with ideas.
And the other thing is nowadays this design thinking is being very much emphasized. So for this kind of visually impaired and building some kind of assistive devices for them. So do students go and talk to the real visually impaired group of people and get their real needs?
Absolutely.
Collect that requirement.
See, I would say we are quite fortunate. First few years we struggled. So of course when we started on the visually impaired set of projects, we got actually the whole stream of VI projects started after I met one Mr. Dipen Manocha, who is a very, very technologically savvy but blind person, who gave me the initial ideas, and we got linked to the National Association of Blind, which is quite close to IIT Delhi in Arkepuram. And in the last 10 years, we had 2 blind people always working in the lab. They actually belonged to that organization called Saksham, but they were deputed in our lab. So the students had very easy access to visually impaired. Of course, the 2 is not good enough if you want to do a product, but at least for concept and prototype, this was okay. So they could interact with this staff who were working in our lab, and they could get some basic inputs. If they really wanted more inputs, they would go to the, let's say there are many projects I have not talked about in the tactile domain, and the tactile books, where students would very often go to the blind school and interact with the students who are studying in the blind school. So that
that's really inspiring, sir. Actually, you also have made it as a economically viable option also for our country, like because if it is really expensive, the sort of smart cane, then people cannot afford it. So you have also made it as a affordable device, I guess, right? Can you just tell something about it, that is how it compares with other market solutions?
No, when we started this project, there was only one solution available. Actually, we did not even realize that the solution was available, because the solution had actually come before SmartCane came. It again came out of a university, and it was a device called UltraCane, which was being produced in UK. It went out of production for a couple of years. When we started doing the patent search, then we realized that this device was actually there. And then it again reappeared. Okay, so maybe they had some difficulty in between, and they've been marketing this device much before we started our SmartCane, except that the device was costing 68,000 rupees. And not only in India, but even in Western countries and US, very few people have even used the device, or mostly they found it expensive. Because please remember two things. Many of our solutions are quite for local needs. One is, of course, affordability, as you have talked about. That was very important, because many solutions that are available in US, Europe, Japan, and Canada, these are all countries, Australia, these are all advanced countries where the government subsidizes even very expensive devices for visually impaired students and users. India, we have some subsidy scheme, but which is very limited. Okay, and that's also not available to every VA person. So now the issue essentially affordability was very key. But apart from affordability, if you look at mobility, our environment is completely different, because if all of you traveled abroad, especially
unstructured environment which we have,
so you never see a sleeping dog on the road, which is very common in IIT Delhi, and I'm sure it's or a sleeping cow, or a standing cow. The cow won't move. You have to move around the cow. Okay, so this is a very common thing in India. It doesn't happen in developed. So this is why non-contact detection is useful, and you will not have an air conditioner sitting, actually jetting into the corridor, or a room cooler jetting onto the corridor. These things are unacceptable. See, we don't even realize, when you actually get a building permission, you are told to, and the building permission, you have actually said, I will have a 3 feet or 4 feet corridor. You cannot block any part of that corridor. It's not legally allowed, but we do it, all the time. We have even government offices will have air conditioners sticking out. Forget about private homes. And at least half or 1/4 or 1/3 of the corridor will be taken. And the blind person move along the wall for reference. And these are things which could really hurt them.
Thank you so much, sir. Somebody else has just commented saying, Samir, so he's saying we are offering a course on cyber physical systems in our department, and we ask students to complete the modeling and implementation using hardware, and that is for PG students, it seems, and he has just made an observation about it. There is no question there. It's really interesting, sir. Very, very, very inspiring and interesting talk. And I'm sure the faculty members and students who have attended this webinar today, they would have gotten lots of valuable takeaways and how they should go about and get these sort of, get the requirements from the real needs of that particular group for whom you are building such kind of assistive devices or this kind of, I think even for your this onboard that project also in the bus, for that also probably you would have done some survey to get the requirements regarding what exactly.
Onboard was, we couldn't even imagine the need for actually locating the entry door. You don't imagine that that's a challenge, but that's a big challenge for, and in case of onboard, I'll tell you one more thing. Though we devised a solution for the blind people, but once we did the trials in Mumbai, we did it on 25 buses in Best buses on 2 routes in Mumbai. The general manager of Best, when we went to thank him for making his facilities available, he said that though you may have conceived for the blind, this is extremely useful for other people, pregnant women, older people, because it alerts the driver and conductor that somebody, they may be able to see the route number, they may also be able to see the entry door, but they will take time to come to the entry door and board the bus. They need some time.
Yeah.
And if the driver doesn't see them, he will take off immediately, as soon as he thinks that the people have got on the board. Because it speaks out the route number, it actually alerts the driver and conductor that there is somebody with special needs is actually wanting to board the bus. So that audio cue part of it is useful in a very different context than what we actually have imagined. Okay, these are some of the very interesting things that happen, that you think that you're doing a design for one section. And that is why he was very keen that we should sort of, implement it on a very large number of buses. We're still struggling to get the funding for that, but it was pointed out not by us, but by the general manager of BEST.
Yes, sir. Basically, it kind of brings empathy into picture, and also inclusive kind of a design, inclusive design for several groups of people, not just the different.
His point was not just empathy. He says it puts actually a moral pressure. Now that he knows that there is a person with special needs is wanting to board the bus, so it puts a moral pressure on the driver and the conductor.
Not to take the bus before they are boarding.
So wait for the person to.
Thank you so much, sir. I think we have reached the time, and thanks all of you for. I would really like to thank Professor Balakrishnan for that extremely interesting and inspiring talk. And thanks to all the participants for attending this webinar this evening. So if you have any further questions, you can feel free to reach Professor Balakrishnan. Maybe if he has time, he can reply you. And you can access this presentation and recording from ACM India's website as well as iSIGCSE website after a few days. And I would like to take this opportunity to encourage the faculty and students who have attended this webinar to consider becoming ACM professional and student members if they are not already. And it is really a very nominal fee, so you can contemplate becoming members. And faculty who would like to contribute to the cause of improving the quality of computing higher education, kindly consider becoming members of the iSIGCSE chapter. The membership is entirely free. Please look forward to another announcement of our next seminar. Until then, goodbye. Thank you very much.
Thank you.
Thank you, sir. Thank you very much, sir.